Okay, so we're going to talk about, so we've already done naming binary ionic compounds, and now we're moving on and adding something that's just a little bit more complicated to get a different, a more robust understanding of how to name compounds. We're still working with binary compounds, so that means that we're still going to have two elements present in our ionic compound, so it's still ionic and it's still binary. But in this case, we have what are called multivalent compounds. So ionic charges on the periodic table, I should say. So there are ionic charges on the periodic table, like you can see here in this image here. There are ionic charges on the periodic table, and some of those ion charges there's actually more than one. Some of them have only one ionic charge or ion charge, but others have more than one. So for example, if we take a look here at copper can form the ions of 2 plus and 1 plus. So what does that tell us? That tells us that some elements are capable of forming more than one type of ion. And these types of atoms are called multivalent. Multi meaning more than one, and valent meaning valence electrons, okay? So we use the Roman numerals given in parentheses. So we use Roman numerals given in parentheses next to the name of the cation, that is the multivalent ion, to indicate the ionic charge. So most of our multivalent compounds that we're going to talk about, actually all of them, are metals, which means that they're all cations, and they are going to have these Roman numerals in parentheses beside them that tells us what the charge of that particular ion is. So here are some typical multivalent elements. So we have copper. It can have charges of 1 plus, 2 plus. When you write your ionic notation for copper, it would look either as Cu plus or Cu2 plus. And the names of those elements are respectively copper 1 and copper 2. Okay, and here are some other ones that are often used in grade 10 and that you should be pretty familiar with. So how do you write chemical formulas for multivalent compounds? They're written the same way as the other ionic compounds. So that means you always state the cation first, and then you put the anion with a change of ending second. But what we're going to do for our multivalent compounds is we're going to make sure that the Roman numeral is in parentheses after the metal, and that indicates the ionic charge of that particular cation. So here you have, for example, tin iodide, okay, and the tin 2 iodide. Okay, sorry about this. This is wrong here. So when you read something like that, it'll say tin 2. You read it as tin 2 iodide. Okay. Tin 2 iodide indicates that the cation SN2 plus is the one that's present in this compound. So again, if we're doing our crisscross method, we have SN2 plus and iodide is a 1 minus, okay? And again, if we're going to do, if we have a 1 minus, it can just be a minus sign, sorry. So really this should look like this. Okay, we do our little crisscross and we end up with our chemical formula, which is this. Okay, and because we don't need to write our 1, we're just going to leave it as that SNI2. That's our chemical formula. Okay, so how are they named? The Roman numeral is added in parentheses after the name of the metal. It's important to determine the total charge of the anion to determine the charge of the multivalent ion. Okay, so again, this is coming back to this idea of a compound having a net charge of 0. Okay, so compounds should have a net charge of 0, which means that when we look at our multivalent compounds, our multivalent ions that are in a compound, so when you see a chemical formula with a multivalent ion in it, you might not necessarily know what the name of that particular compound is, because we have to determine what situation that metal is in, that cation is in. So in order to do that, we're going to have to use the anion and decide and figure out what its total charge is, and then kind of work backwards to figure out what the cation's total charge is. So if we take Fe2O3, okay, so that's, you've been given this chemical formula, Fe2O3, and I've asked you to name it. So you know that oxygen, or the oxide anion, has a charge of 2 minus. And when we multiply that charge of 2 minus by 3, right? Because we know here that there's 3 oxygen in this compound. So we're going to take that 2 minus, we're going to multiply it by 3 because we have 3 oxide ions. It gives us a total charge of 6 minus. Okay. Iron can be in the form of iron 2 or iron 3, and that would be information that you would gain from the periodic table. So it would be in the form of iron 2 or iron 3, so it could have a charge of either 2 plus or 3 plus, because it's multivalent. We're not sure which one it is. But in order to be able to determine what the name of the compound is, we need to know whether or not it's iron 2 or iron 3 in order to properly name it. So we want to make sure that the whole compound, the entire compound, has a net charge of 0. So we have to determine the charge of the ion that will counterbalance the total charge of the anion. And in this case, the total charge of the anion is 6 minus. So when 2 iron ions are multiplied by the charge of 3 plus, and you might have to do a little bit of trial and error here, but we know that if we multiply 2 by 3, we're going to get a charge of 6 plus. Okay, so again, when 2 iron ions are multiplied by the charge of 3 plus, the total charge is 6 plus. And that means that we have a properly created compound with a net charge of 0. What that means is that we have the iron that is present in that particular compound is 3 plus. And the name of the compound is then iron 3, in parentheses, oxide. Okay, I'm sorry about this. There's a whole bunch of loads here instead of charges. I'm not really sure why. All right. Second example, FeO. So we're going to do the same process again. So we're still working with iron, but we have a different chemical formula. So what we're going to do is we're going to start with the same, so oxygen iron rather. So we're going to start with our anion, of course, and we know that the anion has a charge of 2 minus. When the charge of 2 minus is multiplied by 1, that gives us a total charge of 2 minus. Iron can have a charge of 2 plus or 3 plus. And so when iron 2 plus is when 1 iron ion is multiplied by the charge of 2 plus, that will give us a cation charge, a total charge of 2 plus. And 2 minus with 2 plus, that gives us a net charge of 0. So we know that the particular type of iron ion that is present in this compound is the 2 plus of the 2 plus variety. And the name of the compound is going to be iron 2 oxide. Okay, that's it. So that's naming multivalent compounds.